Good evening, everyone. Is the screen visible to you guys? If anyone may confirm that the screen is visible to all of you. I hope you guys can see the slides that I've shared in the screen. Okay, I think few students are still joining the class, so let's wait for 5-10 minutes. I think 5 more minutes I'll wait and then we'll start the class today. Okay, so shall I start the class? I think we can start the class and let everyone else join with time.
Okay, ma'am. Okay, ma'am.
Okay, so this time I thought of taking this class a bit differently because since I've observed that we just have 10 MCQ type questions to discuss from the previous year assignment, and since this class is supposed to be of uh, approximately 1.5 to 2 hours. So it's practically impossible to have that long class by discussing just 10 MCQ questions. And since you guys don't have that much doubts also, so I thought that maybe we can have a quick revision of the lectures of that corresponding week. Like, for example, today we are discussing week 2. So I thought we'll have a quick revision of the content that was uh, covered in week 2. And after that, we'll have the question answer session. I think by doing this, you will have a revision also, and then you'll be able to solve those questions very easily. So, is it fine with you all?
Yes, ma'am. That would be very great.
Okay, okay. So, let's start with the session. And So basically, this week was started. The previous week was started with the basics of the risk assessment. So earlier in week 1, we have read something about the sustainability, and after that, the some content was covered with the risk assessment also. So anyone of you, if may tell me the definition of sustainability, like how you define something to be sustainable. Anyone who remembers this sustainability concept?
It's fulfilling the need of present generation without compromising the need for future generation.
Correct.
Yes.
So this is what sustainability stands for. So we have seen that these sustainability issues are a bit complex, and understanding their interactions with an equally complex engineer systems, it is done basically through well structured analysis, and this is what we do through life cycle analysis, or LCA. Then these risk-based frameworks, these have been traditionally used in the characterization and prioritization of environmental issues. Like if you want to, if we have, say, some concurrent issues, some of the issues that are going one after the other, or together, then how do we characterize that, which issue to be solved first, or how do we decide that which is more harmful and which is not. So that is why this risk-based frameworks or risk assessment, that is where it comes into picture. And then increasingly, however, life cycle frameworks are gaining prominence as a means of characterizing and understanding sustainability. As explained earlier, basically these life cycle frameworks, these are being used to understand the sustainability concepts. Okay, so basically, what is risk? Anyone just try to explain this in a very simple language. Like, how do you say something that it is termed as a risk?
Remember, likelihood of being affected by the hazards prevailing is risk.
Yes, correct.
So we can
So
also say
basically,
that effect of the uncertainty.
yeah, but what kind of effect? Like, it can also be a positive effect also, right?
Yeah, uncertainty can be a positive or negative in that way.
But
Risk may
I
be
think,
positive or positively, or risk may be positive or negative risk also is there.
but I guess here we are considered more about the negative side, because we are doing risk assessment, and then we'll be discussing this toxicology terms also. So here,
Yes, yes, yes.
I guess we are more concerned about the negative side of the uncertainty involved.
Maybe the harmful effects, we can say.
Yeah. So basically, this is defined as the potential for an individual to suffer an adverse effect from an event. So this concept of risk is used in many disciplines, such as finance. Like if we invest somewhere of in financing, so there's a risk involved. Then engineering and health, like the risk involved in construction practices. We know that healthcare facilities also involve a lot of risk. And basically, the definition of the risk can vary depending on the application. Where are we concerned about this? So the definition varies point to point. So let's consider this environmental risk. So these can be basically be grouped into general categories. So see, before starting this term environmental risk, uh, can I ask you one question that somewhere we have heard this term environment, and somewhere we have this ecology. So, what is the difference, basic difference between this environment and ecology? How do you differentiate between these two terms? Because these are confused with one another.
Maybe environment means land, air, water. Ecology may be all living organisms considering.
Yes, sir. Correct. So this environment is the interaction between the all three components like air, water, and soil. And then ecology, it is the interaction of the organisms with the environment. So that is ecology. So like very often these terms are being confused with one another. So that's why I thought of taking this. So these risks were grouped into three general categories. So first was risk involving voluntary exposure. Uh, okay, so if is it fine if I take this class like a mix of both Hindi and English? So I think that would be more fluent, and I think if you guys are comfortable, everyone understands both the languages, or is there some students who don't understand it?
Hindi is more comfortable.
Yeah,
Yeah,
that's
that
why
will be
because
fine.
I think
I don't know Hindi.
uh, okay,
Still,
okay, okay,
still,
yeah.
ma'am, we can use English.
Still
Yeah,
you
that
can
because
combine.
I thought since I want this class to be more of an interactive sort of session, this is not something that I just keep on telling and you guys just listening. I thought so that is why I thought English will be better mode of communication. But if you guys are not comfortable,
Ma'am, one can respond in his own way. You please proceed.
yeah, yeah,
हिंदी में भी बात करूँ. मैं हिंदी में बात करना पसंद करूँगा वैसे तो.
sure, sir, sure. हाँ, because that is better way to explain terms. तो risk को define group करने के लिए we have three general categories. तो first is risk involving voluntary exposure. तो वॉलेंटरी एक्सपोजर में क्या आएगा कि जो भी एक्टिविटीज हम कर रहे हैं जिससे हम वॉलेंटरीली एक्सपोज हो रहे हैं टू सम सॉर्ट ऑफ रिस्क. फॉर एग्जांपल अगर हम जा करके ऋषिकेश में बांजी जंपिंग कर रहे हैं तो दैट इज अ
Excuse me,
सॉर्ट ऑफ.
ma'am. It will be better if we continue in English itself because there are few non-natives of English also are there in the class.
ओके फाइन ओके.
Okay. Thank you.
Okay, so these are the risks involving voluntary exposure, where we are voluntarily exposing ourselves to certain type of risk. For example, doing the skydiving or mountain climbing or bungee jumping. So these are some sort of activities that include your voluntary risk. So we know that these activities poses some sort of risk that is very obvious, but still we are doing it by our free will. So that is your risk involving voluntary exposure. Or other example, if we say that we know that certain places have some sort of pollutants. For example, if we go to some industrial areas, we know that we'll be having certain type of toxins or pollutants, but we can't help it. We have to go there. So that is your voluntary exposure. Then risk associated with natural disasters. So, for example, we have landslides, floods, hurricanes, so which are beyond the human control. So, the exposure to the effects of these certain natural disasters, this can be this can't be controlled by the human beings. So these are the risks that are associated with the natural disasters. Then we have involuntary exposure. For example, the risk that is associated with the release of a certain compound into the environment. For example, during the farming practices, the farmers use certain pesticides or the fertilizers into they put them into their fields. But during this process, they are exposed to those chemicals. So that is a risk that is that involves involuntary exposure, that you can't help it. You directly cannot control the exposure. You just have to be there. So that is the risk that is involving involuntary exposure. Now, release of the chemicals to the environment. So basically, the chemicals can be released to in the environment in three different forms. First is the release to the atmosphere. Then we have release to the surface waters, and then release to the land. Atmosphere. How the chemicals are released to the atmosphere, like from the chimney stacks of the chimneys, stack emissions. This you can read in your like air pollution segment, that we have certain chemicals or the certain toxins that are released through the stacks to the atmosphere. Then released to the surface water, that some industrial discharge, they release different chemicals to the waters, like for example some river streams or lakes. then release to the land. So this can be during farming practices like application of pesticides. So these are some of the examples of the release of the chemicals to the environment. Then we have see how do we classify this environmental risk? So this can be defined as a function of hazard and exposure, both. Risk is defined as a function of hazard and exposure. So what is hazard? Hazard is basically how much dangerous a particular substance is, or how much dangerous a particular event is for the organism. So how much hazardous is, that is your hazard. And exposure is for how long, like this is the time constraint, how long we are exposed to that incident or that like substance. So that is your exposure. So for example, if we say that a substance is very much hazardous, like its hazard value is very high, but we just uh, get exposed to it for a fraction of seconds, or say for 2 3 seconds, then the risk involved will be very less as compared to the situation when we are exposed to a longer fraction of time. So that is your environmental risk, which is a function of both hazard and exposure. Now coming towards the risk assessment. So basically,
Sorry to interrupt you. I have one question.
yeah,
The environmental risk we have mentioned here is a function of the hazard and exposure. Can we
yes.
take it to the control and the detection point also in the term of the function of the environmental risk? Because if we can control the risk, then the magnitude of that risk can be reduced.
But that comes into risk, that comes to the risk management. Here we are finding out naturally how to categorize an event as a risk.
In the I think the risk management is a further part to reduce the risk. If we have a certain control at the initial stage, and at the risk management stage, we can have a further control, better control to reduce the risk at the minimum level.
Then how would you classify a certain activity, or how would you classify a certain event to be risk?
Because
Up,
if there is some chemical in the drum or some chemical in the tank, so it is having a pressure, a vaporized pressure, which need to be exceeded from the certain point that can be hazardous for the people and the environmental also. So we can have that detection of that control point at that stage.
I guess. Okay, fine. So I guess this control thing that comes into this hazard function only. Because if we are somehow reducing its impact, then ultimately this hazard factor will be decreased, right?
Right.
So uh, getting my point, because somehow you are just ultimately trying to reduce the value of hazard. If you are using any kind of mitigation strategy, then ultimately what you're doing is you're just decreasing the value of this hazard term.
Also in our industrial.
uh,
এইখানে সমস্যা
I guess someone's mic is on. Can you please turn it off? We are getting disturbed in the class.
Because we are confused, because in our industrial practice, we also use that framework to consider the control and the detection point at the initial stage. And further at the risk management stage, we further evaluate whether we can further control to the reduced level. So that is what I got to ask, because that is fine, because hazard and exposure is a terminology which is also mentioned in the standardized practice. But I'm just asking whether it is need to mention at the
So
initial level.
Sureshji,
my
Sureshji, you are
yes, sir.
right, but ma'am is seeing the basic definition of the risk. You are moving ahead. Next step, what you are talking is the
Exactly.
next step. Risk management is the next step, and you are also right, but ma'am is seeing the basic definition of risk at present. We are focusing on that only.
You're talking about a particular scenario, like for example you are telling about that industrial risk. So see, if we move further and include different sections, or if we move towards different scenarios, the definition will certainly have different components. And I guess
It's
that's
okay because let's
yeah.
go ahead.
Okay. Fine. So basically, what is risk? We have discussed this term very well, that this is the likelihood of harm, including both like acute and chronic. So basically, acute are your short-term effects, and chronic are long-term effects, like long-term exposure effects to human health and the quality of human life, then our ecological systems, then economic systems. So basically, we are considering all the three type of impacts that we can have from a certain activity. Then what is risk assessment? So the risk assessment is a process by which the form or dimension and the characteristic of the risk are estimated. And basically, in this risk assessment, we are concerned both about the qualitative and the quantitative impacts. And then we go forward towards the risk management. So this is a process by which a risk is controlled or reduced. So these terms we'll discuss in detail in our further class. So, for example, here we are reading about this cancer risk. So the risk of having a cancer is 1 in a million. That one person per 10 raised to the power 6 is at the risk of cancer. And this is what is epidemiological basis. So this is epidemiological is study that is being done on human beings, and this is epidemiological basis for human risk calculations. And second, we have animal testing. So it is not possible every time that we perform some experiments on human beings. So what we do is we perform those experiments on animals, for example rats, or rabbit, or in some cases in foreign countries they often perform certain experiments on monkeys, because their body is very similar to that of human beings. So that is, animal testing is done where human data are unavailable. And mostly the risk assessment is done by this process only, animal testing. But just for certain situations where human exposure is documented, for example, considering the case of exposure to ambient air pollution. So we have certain human exposure data. So that is your epidemiological study. Then familiar risk. So these are some values of risk that are involved in our day-to-day activities. For example, the reference point is 1 in a million, and below this point, below this 1 in a million, the USDA doesn't consider the risk from a food additive to be a concern. So any value which is more than 1 in a million, that is considered to be a potential risk. Then we have two values, that is minimal and very high risk. So minimal risk is 1 in 10 raised to the power 10, or 1 in 10 raised to the power 12. And very high risk is 1 to 0.01. This is very high risk. So these are some day-to-day activities. For example, the risk associated with day-to-day activities, droning in a tub per year. The risk involved is 10 raised to the power minus 5 to 10 raised to the power minus 6. Death in an airplane crash, 10 raised to the power minus 5 to 10 raised to the power minus 6. Death by automobile accident, that is 1.7 into 10 raised to the power minus 4. Death by lightning strike, 10 raised to the power minus 3 to 10 raised to the power minus 4. So basically, these are some of the relative values of the risk associated by different activities. Uh, these are just for the understanding point of view. Now, coming towards some of the basic principles. So, risk assessment, as told earlier, that it is a determination of the probability that an adverse effect will be produced. So, it is true that all human activities possess some sort of risk. And here for the risk assessment, we are concerned mainly with the risk from exposure to chemicals. In this subject or in this class, we are concerned mostly with the risk that is associated from the exposure to the chemicals. So what is the extended definition for the risk assessment? That is, it is a methodological approach where the chemical exposures are identified, analyzed, and for the dose response relationships and quantified for risk estimate. So this, what is this dose response relationship? We will see that in this dose response curve. After that, what is the ideal approach for a risk assessor? How to how to assess a risk? So first of all, we'll calculate the amount of chemical that is absorbed into the human body. Then we'll compare this absorbed dose with the EPA's safe dose for non-carcinogens. And this EPA safe dose for non-carcinogens is termed as your reference dose. Reference dose. And see, EPA does not recognize a safe dose for carcinogens because any sort of exposure to carcinogens poses some amount of risk. So that is why there's no safe dose for carcinogens. For carcinogens, we have risk-specific dose. So these are two types of doses for the carcinogens and non-carcinogens. Now coming towards your dose response curve, basically, see, for a certain compound, like how to understand its what amount will have a certain impact on an organism. So what we do is we increase the dose of the compound and understand its effect. So this data can be, for example, when the dose was very less, so that there was no impact. After a certain point, we have a value where we are we are having certain visible effects. Then as we go on increasing the dose, the effects is increasing. And after a certain point, what will happen is beyond a certain dose, there's no effect. So what are these 2 points? This one and this one. So first is this threshold value. Below this value, there is no effect. And as we go on increasing, this point is your maximum effect range. Because beyond this point, there is no increase in the effect, but we have reached the maximum effect. This is your maximum effect. And this is the your range of increasing effect with increasing dose. So this curve of dose response follows a S pathway. So this is often termed as S curve. The dose response curve is often termed as S curve. Okay, now coming back towards the cancer risk. So in this history of epidemiology, only a few environmental agents have been repeatedly and strongly linked to human cancer. So first is cigarette smoke. Both active and passive smoking lead to can be carcinogenic. So if anyone can tell me what is active and what is passive smoking?
Active means when you directly smoke a cigarette, and passive is the nearby person being affected because of the fumes and the emissions.
Correct. So these are the active and passive smoking situations. Then for the alcohol consumption, this is also carcinogenic. Then ionizing radiations, some drugs, some occupational carcinogens, and some viruses are also carcinogenic. Then these are the cancer is suspected based on observational epidemiology. So many epidemiologists require enough increased risk by factor of 3. So risk ratio with cancer is considered as 3 to take new cancer seriously. These are the example of risk by gender, and also the risk ratio and site is given here. So taking a high cholesterol diet in males, the risk ratio is 1.65, and we tend the site for cancer is colon cancer. Taking high fat diet in females, the risk ratio is 2, and the site is breast cancer. For vasectomy, we have the risk ratio as 1.6, and site is prostate cancer in males. Tap water having
Ma'am, it means that by undergoing vasectomy, chances of prostate cancer increases.
yes, according to this study, certainly the risk involved is 1.6.
But it is never being told to the patient or to the person who is undergoing this activity by doctors also.
So I don't know, maybe in medical terms, they are more concerned about the
Population
uh,
growth.
yeah, I guess.
Okay.
Then
So,
psychological
ma'am,
stress at
exactly what is the risk ratio? How we calculate this risk ratio? That how we come to the this 1.65 to 1.62 to 4?
okay, let me just take this where we have discussed this risk ratio. I think risk ratio. Just a second. So basically, risk ratio, it is the probability of an outcome to the in an exposed group to the probability of an outcome in an unexposed group. So we have some formula also for this risk ratio. You can check it online because I don't think this was discussed in the class. Now, hello, you're not audible, I guess.
Screenshot
Hello,
হিসেবে CTR হ্যাঁ
I guess you guys are talking among yourselves or something else because I'm not understanding. Chalo,
screenshot
okay, fine. I guess I should move further. So, coming towards the risk definitions, we have applied dose, then we have absorbed dose.
এখানে যাই এখানে পরে সেখানে
Pardon,
চেক
please.
হবে আগে স্যার
Okay. So what is the applied
স্যার
dose?
ছেড়ে ছেড়ে ছেড়ে
Suresh Karmakar, I think, if you may mute. Fine. Okay. So what is the applied dose? The amount of chemical in a medium that is available for the uptake, or so that is the applied dose. Absorbed dose, that is the it is the amount of chemical that is absorbed into the body. See, not all the chemical that is given to the organism is absorbed by the body. So, for example, uh, let's take a very simple example. If we have fever, we take a simple medicine like, for example, paracetamol, and it's the dose that we take is, for example, if we take a tablet of 1000 mg or 500 mg. So it's not necessary that whole of the medicine is applied by the is absorbed by the body. Maybe it's quite possible that we absorb only 10, 15, or 20 mg of the medicine, and rest is just flushed out through the body in different forms. So that is the difference between your applied and absorbed dose. Then we have a reference dose. So this was discussed earlier. That is the dose of a non-carcinogen that is believed safe for humans. And this reference dose usually extrapolated from an animal toxicity data, and this we'll be seeing further from a graph. Now we have risk specific dose. This is the dose at which 1% in a million exposed people will develop cancer. Then we have hazard index. This is the ratio of absorbed dose to the RFD, like reference dose. And if hazard index is less than or equals to 1, that is an acceptable situation. And if hazard index is more than 1, then we need to have the chemical concentration is needed to be decreased. Now coming towards the risk management, the process of factoring the risk assessment versus possible alternative actions. We have cost benefit considerations, then the need of the consumers are to be taken into account. Then we have some alternative, we can have some alternative chemicals also. So this all comes under the risk management. So we have certain processes for risk assessment at a site with drinking water. So first is your in the first process, what we do is we have hazard identification. So we just test the water sample to find out what chemicals are present and in what concentrations. Then we find out either if they are carcinogenic or carcinogenic. Then after that, we have some dose response assessment to find out the dose response relationships. We find out that curve, and then after that, if we establish this dose response relationship, then we go for data validation. And then get if when we get this dose response relationship, then we can extrapolate this data to find out the reference doses or risk specific dose data from animal studies. Now, for the second process, for human exposure assessment, we need to assume some exposure. We need to have some exposure assumptions. For example, assume zero point 0.5 milligram per liter of zinc in drinking water. Then, if we assume that then adult on an average intakes 2 liters of water per day, and his weight is approximately 70 kg. So the dose will be 0.5 milligram per liter multiplied by 2 liters per day for 70 kg. So for 70 kg weight, so the dose will be equals to 0.0143 milligram per kg per day. For the third process of risk estimation, we compare the absorbed dose to the RFD or RSD. Then if HI if risk is greater than or equals to 1 in a million, or HI is greater than or equals to 1, then cleanup is required. And for example, if like considered earlier, we got this dose as 0.0143. So no, then if to find out the HI value, we divide this by the average RFD, that is 0.2 milligram per kg per day, and we get the HI value is 0.0715. Since this value is less than 1, so no cleanup is required.
I have a question where we have taken this 0.2 milligram per kg per day.
This reference dose for zinc example.
So is this any regulatory requirement or any
Yes,
requirement?
yes, the reference dose is fixed, right? The reference dose is the maximum amount for a carcinogenic substance. So this is this value is fixed.
For the carcinogenic, we take the reference specific dose. Now, for the reference dose, I think is for the non-carcinogenic disease.
No, I guess you're telling.
Yes. The reference dose is for the non-carcinogenic.
I just got confused. Sorry. So
I
the
think,
reference.
ma'am,
Okay.
I
Yes.
think it's standard value prescribed by EPA, something like that. Sir
Yes,
was
sir.
telling.
Yeah,
We
it
are
may
talking
be
about
standard value, I think. Yeah, it
standard
may be
value it
standard
is,
value. Yes,
given
yes,
from the
yes.
standard.
Right, right.
As
Totally.
prescribed by EPA,
Yeah,
USA.
these basically for drinking water, we have standard values for every parameter, for example, for iron, manganese, even fluorides. So these are the reference dose values that are prescribed for, by the EPA. Then to find out the hazard index, we just divide this by the reference dose. And if this value comes less than 1, then no cleanup is required. And then if this value is more than 1, then we need to take some measures to clean that water. Okay, so development of reference doses for safe human dosage. So we have these two levels, NOL, no observed adverse effect level, or LOL, lowest observed adverse effect levels. So dividing these two factors by the uncertainty factor, that is a number between 10 raised to power 3 to 10 raised to power 4. So uncertainty factors value is 10 for data uncertainty, 10 for interspecies extrapolation. Then we have 10 for extrapolation between routes of exposure, and for protection of sensitive individuals, we have 10. Now, to determine the maximum contaminant level goal, MCLG, for drinking water, so the for category 1, that is a known carcinogen or probable carcinogen, the MCLG value is 0. For category 2, we have MCLG is equals to drinking water equivalent level divided by the slope factor. And we'll be having these slope factor and this NOL and LOL values in further in coming classes. So coming towards the next term, that is toxicology definitions. I think I need to speed up a bit because we don't have much time. So what is toxicology? This is the study or science of poisons, and these are the chemicals that produce adverse effects on the organisms. For example, we can have certain diseases or skin infections, or it can also lead to the death of an individual. So basically, toxicology is the study of how chemicals reduce an organism's ability to survive and to reproduce. So some of the basic definitions include toxicant. This is a substance that is man-made, or this results from human or anthropogenic activity. Toxin. These are the substances that are produced naturally or released by our living organisms. Then we have for like effects or exposure, we have acute and chronic. So acute is short single exposure or response, and chronic is long continuous or repeated exposure. Then we have latency. So this is the latency is the time period between the exposure and the response. Like there's a specific time period between, see for example, if we have acute toxicity, so the latency period will be less. Like the we have the response as soon as we are exposed to certain environment. For chronic effects, with the latency period will be high. So toxicology. So basically everything is toxic. See, we must have, all of us must have heard this term. Too much of anything is dangerous. So there's a famous quote that all substances are poisons, but there's none which is not a poison. But the right dose, it's the right dose that differentiates a poison from a remedy. For example, this DDT that is used in the fertilizer. So if we are using it in the right dose, it is not that much poisonous. But excess of this DDT leads to the toxicity in the soil. Then similarly, lead, oxygen, and also water. Now, what are the characteristics of the toxicants? We have 5 points. First one, it should be present in the environment. Then it should be bioavailable and bioaccumulated. This bioaccumulated, we'll discuss this term further. What is bioavailable? So basically, it should be available for the organisms. to be, or species that are exposed to them. Then it must interact at a molecular site, and it must cause a metabolic dysfunction. It should also decrease the fitness of an individual organism. So these are the characteristics of a toxicant. How to specify a certain product as a toxicant. So this is your toxicology graph. Now, the release of toxic materials. So first is your intentional and legal releases. For example, certain industries, we have formulated some guidelines for the release of certain toxic materials. So those are into the water streams. So those are intentional and legal releases. Some releases are due to the activities which have been done for the benefit of the organism. For example, agricultural activities. We have some uh, healthcare facilities. We have certain releases from there. Some industrial releases are there. Then the adverse effects include the toxic responses. Now, the environmental fate, basically the environmental fate of this toxin or the toxic substances. First is the partition. These can get separated into different chemicals. Then their transport, and then they can be transported from one phase to the other. For example, if the toxins are present in the clouds, they can come to the ground in the form of rainfall. Then these get transported from the atmosphere to the lithosphere and the hydrosphere part of the ecosystem. Then they can also get transformed by various means, for example, for by photooxidation or some other means. So this is the environmental fate of the toxins. Then what are the different routes of the exposure of to this toxins? First is your through your GI tract, that is through dietary means, food and water. Second is your skin exposure, that is through your through the skin of the organism. Then we have pulmonary or the respiratory exposure, that is through the atmosphere, that the air that we inhale, we have some exposure to toxins through that as well. Then we have injection or experimental, that is your accidental or intentional exposure to the toxins. So what are the characteristics of these toxins that we have? First is they have large surface area, so that they can be highly reactive. And second, they are highly vascular. So what is vascularity? That is, it is able to be carried in the circulatory system with the blood and lymph throughout the body. So this way these toxins travel throughout the body. And how they get eliminated? So the major systems for the elimination of toxins from the body is, first is through renal or urine, second is biliary or liver, then pulmonary or through the lungs, and some other minor routes of the elimination are there. That, for example, during if we are sweating, so some of the toxins are also released through through by our skin also. Then binding. So basically, binding of the toxins, first is the interference with the normal receptor, for example, our neuroreceptors or the endocrine system or the enzymes. Then interference with the membrane function. Some toxins interfere with the cell membranes, that or neuromembranes or organelle membranes. Then interference with the cellular energy production, for example, for the oxygen transport, oxidative phosphorylation, etc. Then some toxins may also get binded to biomolecules, for example, enzymes or lipids, DNA, etc. How this toxins response, like after they get transported and they react with our body, what are the kind of responses that we get? First is the death of the organism, second is organ system failure or some sort of tissue damage, then we have diseases or other sorts of responses. Then for repair of this or repair of this toxicities, first is functional cell replacement or fibrosis or scarring or connective tissue. Then coming towards the chemical toxicity, so we have first is carcinogenic or cancer impacts, and second is non-carcinogenic or non-cancer impacts. Next is toxicity to ecosystem. So impact of on individual organisms, then population level impact. Sometimes we can observe that a whole population of a certain type of organisms get impacted by a certain type of toxin. Then we have community level impacts. So these are the chemicals that have been found to be human carcinogens. For example, arsenic, benzene, hexavalent chromium, vinyl chloride, etc. Cancer, we all know what sort of cancer, what that we know that chemicals cause cancer in different manners, and the time between the exposure and the initiation of cancer can be very large. It can be very, so that is why it is very difficult to identify the causes of the cancer, and also that is why it is not identified at the earlier stages. Then the non-cancer effects, the chemicals can have an effect on the target organs, for example, liver, alcohols, it certainly affects the liver. Then some carcinogens affect the nervous system or the kidney. Then we have effect on the reproductive system or the overall development of an organism. So to quantify toxicity, to quantify how toxic a chemical is, so that we can control the level of these pollutants, we have this formula. Toxic effects is potency multiplied by exposure. Same as the risk. Potency is how toxic a chemical is, and exposure is how much time the organism is exposed to the chemical. So, for example, how do you quantify toxicity? So, when the data regarding the toxic impacts are gathered from the laboratory studies or from the epidemiological studies, the information is gathered regarding the degree of toxic impact at different levels of exposure. So, this is how we gather is we have different level of exposures. See, toxicity is potency multiplied by exposure. Here we have fixed the value of potency and we are varying the value of exposure. So after a certain level of exposure, we observe the impact in the organism. So this is similar to that S curve that we studied earlier. Like this is your maximum exposure, and this is beyond this level of exposure, there is no impact. And below this level of exposure, there is no impact. So this is your complete impact, and here we have no observable impact. So this no observed adverse effect level and lowest observed adverse effect level. So this is your no observed adverse effect level. After that comes a certain point, we have lowest observed adverse effect level, and EC50 is the exposure at which the effect occurs in 50% of the population. So, for example, if we take a sample of 10 organisms, and after a certain level of exposure, the five out of 10 organisms are exposed um, and are showing the effects, then this amount of exposure is termed as EC50. And see, this was done from a toxicity text, and if we have the data from epidemiological studies, so it's quite possible that we have only a few data points, because it's not necessary that we have that much human beings to carry our experiment on. So how can we estimate the effect? We can extrapolate these values linearly, maybe, to find out the values. This will be taking further. We can estimate the effect as a result of the exposure, but what exposure is acceptable? So no, for non-cancer effects, the protective exposure is one when we have no effect. For the cancer effects, we have the protective exposure is one at an acceptable risk, that is 1 in million. So what is your reference dose? It is for non-cancer risks, and the typical unit is milligram of chemical per kg of body weight. And typically the LOL and NOL divided by a series of uncertainty factors as discussed earlier. And these account for unknowns such as differential species, exposure duration, etc. Example for RFD of a oral RFD for cadmium in food is 1 into 10 raised to power minus 3 milligrams per kg per day. In water, it is 5 into 10 raised to power minus 4. And inhalation RFD value is none. What is slope factor? So this is used for the cancer risks, and the typical units is the fraction of population affected per milligram per kg per day. And the same uncertainty factors will be applied. So how do we extrapolate these slope factors? For example, that we considered earlier, like these three data points, if we have linear extrapolation, we get this graph as this. So sometimes it's possible that the chemical is more potent at lower concentrations than predicted by the linear extrapolation. Then we'll be having the graph is must be having like this. And if the chemical is less potent, and then we'll be having less risk at a at a more level of exposure. So the chemical is less potent at lower concentrations than predicted by linear extrapolation. So assessing the risk, the toxicity information, RFD and SF for chemicals in a waste, along with estimates of exposure, duration, and frequency, can be used to assess the risk posed by a waste or contaminated soil, or can be used to set protective limits. So this is the equation to find out the standard for drinking water, uh, for a certain parameter in drinking water. How do we set standards? So first is your T is equals to TR multiplied by BW divided by CSF into WC. So TR is your target cancer risk. This is unitless. BW is the body weight of the exposed population. CSF is oral cancer slope factor, and WC is the average water consumption rate. For non-carcinogen, we have standard is equals to oral reference dose multiplied by the body weight and divided by the average water consumption rate. Similarly, for clean soil standard, the for carcinogen we have C is equals to TR into BW divided by CSF into IR, that is ingestion rate. Here we had water consumption rate, here we are having ingestion rate. Now coming towards the risk assessment. So the risk analysis follow process includes the four step. First we have hazard identification, then dose response evaluation, then exposure assessment, and then risk characterization. After the risk assessment process is completed, then we move forward towards the risk management. So what is risk assessment? So it is a qualitative or quantitative estimation of the likelihood of adverse effects that may result from the exposure to a specific health hazards or from the absence of beneficial influences. So for risk management, it follows risk characterization. It seeks to control exposures to toxic chemicals in the environment, and then it leads into law and policy. After finding out, assessing the risk, we can uh, formulate certain rules and regulations to and fix out standards for certain compounds. Now we'll discuss some chemicals in and the risk associated with them. So first we have polychlorinated biphenyls, PCBs. So these are most widespread chemical contaminant that are known, and these are discharged from factories into the waterways, and these are generated from by the vaporization from paints or landfills or burning of PCB containing material. And this like when we have open burning of the waste, then some chemicals are released into the ambient air, and then these may re-enter the ecosystem by the with the along with the rainfall or precipitation. Next source is the leak from an industrial equipment. Then we have accidental spills and illegal dumping of the PCB waste. Since the legal disposing of the PCB waste involves high cost, so what people do is they dump these waste illegally at certain places. Then we have the threat to health. The laboratory testing shows toxicity even at low concentrations to several species tested, and it leads to certain skin disorder, and it is also a type of endocrine disruptor. So, what are your endocrine disruptors? Basically, it affects our endocrine systems, and what happens here is the male organisms start showing female characteristics. So that is what an endocrine disruptor do. So this is a dredging operation to remove PCB-laden sediment from the Upper Hudson River, which was commenced in May 2009. Then next up we have dioxin. Dioxin, this is some type of carcinogenic substance, and it is formed as a contaminant byproduct in production of herbicides such as Agent Orange, which was used to clear jungle vegetation during the Vietnam War. Then it can cause Parkinson's disease. So what is Parkinson's disease? Basically, in this, the patient starts to lose its balance and is unable to perform the regular day-to-day activities. Then we have ischemic heart diseases or hairy cell leukemia. Then chloracne skin disorder, variable toxicity in different test species, carcinogenic in most species at high levels of exposure, and it is also some sort of endocrine disruptor. And suppression of immune system is also happens due to this dioxin poisoning. So dioxin TCDD, what is this TCDD? It is 2378 tetrachlorodibenzo It is the full form of your TCDD dioxin. So it was observed that former Ukrainian President Viktor Yushchenko is shown in photos from March 2002, that is in the left, and December 2004. So he was scarred by deliberate dioxin poisoning during his 2004 presidential candidacy. Now, next up, we have asbestos. So, asbestos has most probably caused more deaths and disabling diseases than any other hazardous substance. It basically consists of fibrous silicate materials, and when this material is disrupted or is disturbed, then these fibers are released into the air, and when we breathe in such environment, then through our nasal cavity, these enter our body, and these penetrate through our lungs, and then they cause damage. So this is utilized to reinforced clay and clothes since the Stone Age, and it is also some very good fireproofing material. So now the 85% of the asbestos that is used today is incorporated into the cement construction materials, and as explained, some inhaled fibers lodge in the air passage and cells within the lungs, and thereby they damage the tissues inside the lungs. Here, this Libby, Montana, town of 3,000 along the Kootenai River has emerged as the deadliest super fund site in US history due to the decades of contamination with asbestos fibers from a near vermiculite mine. So, what are the diseases that are related to asbestos? First, we have scarring of the lung tissue. Then we have lung cancer. This is the leading cause of asbestos-related mortality. Exposure increases risk 7 times, with cigarette smoking risk is 60 times greater. Then we have a disease, mesothelioma, that is a cancer of lung or stomach lining. Asbestos is only known cause of this mesothelioma, invariably fatal generally within 2 years of diagnosis. So this is an image that is showing the workers in full protective body gear dampen. And these are removing the asbestos material from a high school, because basically this was more used in the old buildings as a fireproofing material, because earlier we didn't have that much options. But now, since we are constructing our buildings using bricks and mortar, so we are not using asbestos as much. Now we can visualize this asbestos sheets in on the rooftops of some of the like places. For example, in some factories, they just place these asbestos sheets on the top of the walls to serve as a rooftop. And then we have lead. So the effects of lead include impairment in the brain functioning, hyperirritability, poor memory or sluggishness. Then we have epileptic convulsions, then coma or death can also happen due to higher lead poisoning. House paint remains most notable source of lead poisoning problems. Also, the 40% of the lead ingested by the preschoolers remain in their bodies versus only 10% in the adults. That this data shows that the childrens are more exposed or have more adverse impact due to lead as compared to the adults. Then this interferes with the blood cell formation and also can damage our kidney. Any amount of exposure carries some degree of harm, which increases as the level of exposure increases. So this was a study that was carried on the children to find out the blood lead levels in the children from 1997 to 2007. These blue bars represent the number of the children tested, and this yellow boxes, these are the confirmed elevated blood lead levels, EBLLs, as a percent of the children tested. So we can clearly observe that as we are moving forward, like as we are moving with time, this confirmed EBLLs are getting decreased, because this is due to the different steps that are being taken to reduce this lead exposure. For example, one of the step that is being taken is the removal of lead from the petroleum or the gasoline. So now we have unleaded petrol, and several other measures, like we have unleaded paints. Now the lead is not being used in the paints of the that we apply on our houses or different types of buildings. So that is why this exposure to lead is getting decreased with time. Similar study we have in US children with elevated blood lead levels. Now, risk assessment and bioavailability. So, what are the advantages? So, if the contaminants are not bioavailable, then they are not included in the evaluation of a risk. And it is it optimizes the cleanup goals with a possible cost reduction. Basically, doing the risk assessment, we can find out which are the target contaminants that we need to clean up, and that is why the some cost reduction is also there. And this also leads to the more effective use of the available resources, and we can achieve more accurate defensible cleanup goals while ensuring the protection of the receptors. What are the challenges associated with the risk assessment? First is the uncertain acceptance by the regulators, stakeholders, and the public. Next, site-specific results, and these are very much difficult to compare across different sites. So we need to follow some standard processes so that we have generalized results which can be compared across different sites. Then it is potentially higher site it has potentially higher site characterization costs, and it may take longer to gain full understanding of the conditions. So these are the challenges associated with the risk assessment. Now, the processes to consider during the scoping. First is the physical processes, the bed transport, deposition or resuspension of the contaminants, then bioturbation, advection or diffusion, then grain size, COPC distribution, burial or the temperature, chemical processes, for example, sorption or desorption, transformation or the degradation, geochemical process, for example, TOC, salinity, pH, biological process, uptake, biotransformation, bioaccumulation, the mode of action, and critical body burden. So this is an example of a conceptual site model which was taken at Anacostia River, like how see, water comes through this is in the form of storm water, sewer from the water treatment plant, or the CSO, that is combined sewer overflow. It comes to this river stream, and some urban tributaries are also uh, entering this mainstream. Then we have permitted facility discharge. Then we have some uncharacterized point discharges, volatile, and then we have influent from a non-point surface runoff. So this is runoff due to the rainfall or the melting of the snow. Then we have precipitation, and some soil erosion is also there along the bed of this channel. So these are all the influent sources. Then these contaminants can get back into the atmosphere through this volatilization process, and depending on the direction of the flow, we have the bed load transport, that the particles can get suspended uh, or deposit on the bed. They can also get get resuspended on the uh, along the flow. So this is the riverside model and the fate of the different contaminants. Then importance of quantitative measurements. So what is the importance of the quantitative measurement? First is it helps in defining the problem. Then the reliable results from various labs or hands we have. Once the extent of the problem is quantified, fix can be designed. It is the basis for several research studies, and it is also used in finding the answers to new problems and better answers to the old one. So character of environmental problems. So the relationships between living organisms and their environment. Analytical procedures used are the strange mix of chemical and biochemical methods. Then we have interpretation of data is related to effect on the microorganisms and or the human beings, and many of the determinants fall in the realm of microanalysis. Now, some standard methods of analysis on the initial days, different methods proposed for the same determinations, and this led to the difficulty in comparing the data coming out from various methods. So we needed to have a comprehensive manual for the which has the standard methods which everybody can refer to, and this led to the development of standard methods of water analysis by AFA, AWWA, and WEF. So these standard methods are normally accepted in courts also. And using these standard methods, a sample that is tested here in, for example, in the laboratory of this college can be compared to a sample that has been tested to a different country, in a different country, because both are tested using the same standard procedure. So these are the contaminant levels in receiving waters. So these concentrations are in logarithmic scale, and here we can see the contaminant levels from bacteria is 10,000. This for the sediments is also the same. For BODs we have lesser contaminant levels. I think this graph has been discussed in much detail in the class, so I won't take it further. Now let's get into the questions part. So the assignment for week 2, the previous year questions that were there. First question is, what is the ratio for cancer? Anyone? 5, 7, 3, 10. Okay, so I'll tell you. The risk ratio for cancer is 3. Now, which organ of the human body has highest cancer risk ratio? Okay, I'll just
Lungs.
get. Yes,
I think
lu-
lungs.
lungs. Correct. It will be lungs. This was discussed. We had a table which showed the risk ratios for different sites in the body. So the ratio for the lung was the highest. Then, what is the unit of reference dose?
B.
Okay, milligram per kg per day. Correct. Then, the Libby town was contaminated by which pollutant? We have discussed this just some time back that this Libby town was contaminated by certain pollutant. The town had a population of 3,000 something, if you guys remember.
Maybe dioxin, maybe.
So it's asbestos fibers.
Oh, sorry.
See, yeah, we have discussed this just this Libby town, right? This was
Thanks.
contaminated
Thanks.
with asbestos fibers. Okay. So, which is used to designate the time difference between the exposure and the response? Which term is used?
Option D, ma'am.
Latency.
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 Correct. Correct. Which of the following parameters are the function of the environmental risk?
Exposure.
A and B.
And
Hazard and exposure.
yes, it's exposure
Or
and
multiple.
hazard. Risk is a function of hazard as well as exposure. What are the key characteristics of the toxicants?
Bioavailability, ma'am.
A and C. Bioavailability and biocommodity.
A and C.
A and C. Okay. So harmfulness, uh, it can also be a key characteristic of the toxicant. It should be harmful as well. But I guess as far as the key characteristics are concerned, the availability and bioaccumulation potential are the key characteristics. Which of the following steps must be considered during the dose response assessment?
B and C. I think.
Yes.
B. Option B.
B and C both. Basically, we are concerned about the discovery of the reference dose or the risk specific dose. After that, when once this S curve was formed, we tend to have the data validation stage also. Then the ninth question is, lead ingested by preschoolers remains in their body in much lower concentration rather than adults. Is it true or false?
False.
False.
False. Because preschoolers, it has 40%, and for adults, it
10%.
remains only 10% of the time. Now, toxicology is the study of how chemicals increase an organism's ability to survive and reproduce?
False.
Okay. So with this, we have discussed all the 10 questions that were there in the previous year's assignment. And
Ma'am,
we
are these
also,
week 2 assignment questions?
yeah, these were questions for the week 2.
Week. Oh, okay. No, when I. Okay. I guess I maybe a confusion. I've seen something else as this assignment questions. That's why I was asking.
So
This is
these are the
previous years.
questions from the previous years,
Previous years.
not this current year questions.
Oh, okay. So sorry, just got
Because
confused.
we are not allowed to like discuss these current year questions in the class until you
Okay,
submit your assignments.
okay. And by the way, what is the actual date for submission of that assignment, ma'am?
Okay, I just have
9th,
to
9th August.
yeah, it was 9th of August,
9th
right?
of August.
Okay, and will we be discussing those questions anytime in this class? Not now, but anytime for
Yeah,
reference.
if you're having any doubts, we can take those questions in the next class, because until your deadline is over, we're not allowed to discuss the same year questions.
Oh,
If you're
okay,
having
ma'am.
any doubt or anything, we can take that, but not discuss all the questions like I'm discussing now.
Okay, okay, ma'am. Okay.
Okay.
Ma'am, I have a question that how we calculate the MCLG for the category 1, 2, or 3 that we have previously mentioned in these slides.
Okay, let me get there. Category 1, 2, and 3. I guess some criterias have been defined, right?
I just need to understand that quickly.
Get there. Is it- Is it this one?
Yes, ma'am, this one.
Maximum contaminant level goal for drinking water. I guess these are the which are category 1. Okay, so category 1 is for substance that is a known carcinogen, or it is a probable source of carcinogenic substance, or it is a probable carcinogen. So that goes for category 1 substances. Then I think for category 3, we have no evidence of carcinogenicity. I'm not sure about category 2 because it has
So how we
not
come
been
to the
specified.
slow factor, these slow factors? What is the D, W, E, L, and how we calculate this slow factor category 2?
Okay, slope factor, I guess there was some graph, right, to find out the slope factor, where we have certain epidemiological studies and we extrapolate that graph, like it was somewhat like this, and we needed to extrapolate this graph. And here we had risk and here we had exposure.
And what comes in the category two, ma'am? Because here is a different formula for the category two, and the for category one, I can understand that that is a carcinogenic, so the CLG should be zero. But for the category two,
Okay, category 2 carcinogens. Let me check once. We have it in US EPA's website. They have specified it very clearly, the contaminants and these MCLG values. We look for the categories because right now I don't know about these specific categories because it was not discussed in very detail in the class. There is also not taken this.
because if any question comes in the exam and for this related to them, it will be
Yeah,
difficult to solve.
I
The
understand your
revision.
concern because yeah, might be possible. But I think no question will be asked apart from the content that is being covered in the class. But still, I am trying to find out the details about. Why don't we do one thing? I just take this question about these categories and I'll try to discuss it in the next class because right now I can clearly see that the US EPA has certain guidelines about these category section, but I need to read it further for that.
Sure, we can discuss in the next class.
Sure, yeah. Just leave your question in the chat box. Just try to share your question in the chat box so that I can take it in the next class. I remember to have it in the next class. Is it fine? Because see, I've also tried to cover all the topics, but certainly I've missed some points. So it's good if you are having any doubts, you just ask it, and I'll try to discuss it. If not today, maybe in the next class.
So that will be fine.
Okay. So okay, so I guess uh, we're done for the day. If any no other doubt is there. Any other question if anyone is having, or I'll just take the attendance and then wrap up this class. Okay, so any questions? So one more thing I wanted to ask you guys. So I guess everyone is fine with this way of taking the lecture. Like initially, we discuss we have a quick revision of all the topics and then the question, or just I just skip the revision part and just take into the questions only. How do you want the class to be done?
That is fine, ma'am. But when there is any calculation concerns, I think we should take a one example or sample example to understand the more better. It will
Okay,
make sense.
I'll try to take certain examples since I didn't have much time. I and today only I tried to cover all the topics. So what I will do from the next class onward, I just take some important topics that were discussed in that week, and then we'll just discuss those topics. So it will be easier to give certain examples regarding those topics. I think that would be better instead of taking all the topics, which I guess it's a repetition of one and the same thing. So instead of taking all the topics, I'll take some important topics and try to discuss them in much depth. I think that would be better. Any other
Yeah, that
suggestions
would be
or
better.
okay? Any other suggestions from your side? Okay, so I guess I'll just end this class. See you guys next week.
Okay.
Yes, ma'am.
Okay, okay. So see you guys next week. Till then, take care.
Thank you, ma'am.
Okay. Thank you so much. Thank you.
Thank you. Thank you.
Thank you, ma'am.
Thank
Thank
you.
you.
Thank you.
Thank you.